Joanna Macris, and today we're here to talk about Lidar, which, as most of you know, is really a revolutionary technology that promises to change the way we think about not only automotive safety, but autonomous driving. And joining us today is Dr. Matthew Weed, Senior Director of Product Management for Luminar Technologies, which is really the leader in this space right now. So Matthew, thank you so much for joining us.
Yeah, no, it's my pleasure. It's always a good opportunity.
Great. So let's dive in. Luminar recently showcased a rather provocative video showing Tesla vehicles, which appeared to be on autopilot, crashing into standing crash test dummies. Tell us more about that, and tell us, really about your views on the state of autonomous driving today.
Yeah, so it's a good question, and there was a lot of subtext that it was not always obvious to pull out from everything that we've done. So really, what we've shown, and it's kind of a good culmination of what we've been driving to as a company for many years now, is to be able to show what's possible at the vehicle function level with this new sensing technology called Lidar. As you mentioned, as everybody in the market is trying to figure out now in the public markets, is what is this Lidar thing? Really what it's all about is giving a vehicle better understanding of what's going on in the environment around it in 3 dimensions in the full context. And what we showed at IAA in Munich last week is the result of our team building an entire software stack from raw sensor data to actuation of a vehicle, the kinds of safety systems that are possible with this kinds of sensing. And so what we showed there was an automatic emergency brake event at much higher speeds than most vehicles that are out in the marketplace can actually achieve now. And that's one of the examples that we showed. We did show Tesla. They're one of the leaders in the market space right now with vehicle capability. But the difference is they're still not being able to address a lot of the core safety opportunities that LiDAR technology brings. And that's really what we were illustrating there with that demonstration.
Yeah. So break down LiDAR for us very simply. What is it and how does it work at a fundamental level?
Yeah, so you can think about it. You're probably familiar with cameras. I mean, you're looking at the result of camera data right now. It's an image. It's two-dimensional. You can do all kinds of processing in it to kind of guess at how far away things are from each other. But ultimately, it is a two-dimensional data. Radar is kind of the opposite. So radar is two-dimensional data as well, but instead of having lots of information here, you only have information radially. So you don't have the ability to understand what things are, but you can see how far away there might be something. What LiDAR does is it kind of bridges that gap. It allows you to understand the detailed understanding that a camera would give you of the size and structure of objects, but also exactly how far away they are. So LiDAR is a technology that uses lasers to understand the distance to objects, but at camera-like resolution. We do that by timing the speed of light and all kinds of really cool technological things, but that's ultimately what it does and how it works.
Yeah. So speaking of Tesla, Elon Musk is notorious for despising LiDAR. And Tesla seems to say that they can go it alone with cameras. So talk to us about, thoughts on that. Clearly, every LiDAR manufacturer, disagrees with Elon, but help us understand, what are the limitations of camera technology versus LiDAR?
Yeah. So kind of like I was actually saying, the camera technology is ultimately limited to 2 dimensions. Anything that's extracted with regards to 3 dimensions, which is what we live in, what the road space is inferred by the data. Now, the argument is that if a human with 2 cameras and a really good computer can drive, then why can't a car? There's 2 issues with this. The first is human eyes are very good, and human brain computer is very, very good as well. And so the equivalent of hundreds of megapixels of camera data is really what we have to bring to bear. The other thing, and honestly, probably more importantly, is that at the end of the day, this whole thing is not about whether it might be possible to drive a car with cameras only. The real question, and what Luminar has really been focusing towards, is will it be safer if it uses LiDAR technology? And that's really what we believe and what we're starting to demonstrate now. Because ultimately, that's the goal. The goal isn't to prove some academic case. The goal is to make vehicles more capable than what a human can do. Humans, for as good as we are at driving, and it's really quite incredible how a good driver paying attention can drive. we're not always paying full attention. The conditions don't always, lend themselves to good driving. And so, bringing new technologies like lidar to make these vehicles more safe is the real goal. And it's not about what can possibly be done with different sensors.
That makes sense. This space is also kind of an acronym soup of different wavelengths used by different companies, different, architectures from MEM-based to, so help us understand kind of some of the key differences and what you see as kind of pros and cons of some of the different approaches to the space.
Sure. So I guess as you said, it is alphabet soup. There's a lot of depth. Our communications team thought it would be nice for me to stand with the background of my education. Lots of time spent studying optics, lasers, sensing technology. And at the end of the day, for most of the world, I would urge to focus on what is possible with the sensing technology and focus less on trying to figure out for yourself who's got the best tech. Let the markets kind of speak for themselves. Who's got traction? The hardest critics in the world are our customers. They're the ones who are basing their business models off of the sensors they select. So that's the biggest thing I would say. But at a high level, wavelength is a really important one. We operate at a longer wavelength than most of the landscape, 1550 nanometers, which allows us to send a lot more energy into the world safely. Shorter wavelengths are much more hazardous for eye safety concerns because they're much closer to visible light. We use much longer wavelength further out in the infrared, allows us to measure much further and much more resolution. Other than that, there's a whole host of architectural decisions, which we've recorded some actually run through. If you go to our website, you can see a kind of a sensory overload review of different architectures. But for now, I think that's probably a good place to leave it.
Yeah, it's complicated. Obviously,
Yeah.
cost is an issue in this
Yeah.
space, and critics, will cite the 1550 nanometer wavelength as being prohibitively expensive. So I would love for you to address that and talk about, where you see costs going and how close we are from a price point perspective of getting to commercial mass adoption.
Yeah, it's really interesting. I think that there's a lot of work that Luminar has been doing over the last number of years is toward exactly as you've said to break down the assumption that it's too expensive to operate these longer wavelengths. This assumption comes from two sources. One comes from the fact that you can't just go to the internet as a random person and buy a bunch of 1550 nanometer components. And most of the LiDAR industry are not actually optics experts. They're trying to buy what they can off the shelf. They're electronics experts pulling these things together and build something that is LiDAR. Luminar, knowing that we needed to go to these longer wavelengths to serve the market, invested really early in integrating that technology ourselves. And so building that supply chain, leveraging what existed from telecommunications and from the defense community to a technology base that is custom designed for the automotive application space, but stands on the shoulders of these existing markets. The other challenge is the architecture stuff. I'm not going to go into in a lot of detail, but if you design the architecture right, you end up minimizing your cost reliance on the optoelectronic components, the receivers, the detectors, the lasers. Those bits will drive the cost of these sensors. And the fewer of those you can have in a sensor, the better. Historically, there's a lot of this technologies that cascade a whole bunch of receivers and lasers and just single point by point brute force the problem. And those have really fundamental cost floors. Luminar's architecture is a one-to-one, and we scan that around the scene to capture the whole environment. And so, architecturally and supply chain, being able to pull all this stuff together is really what's allowed us to get to the cost points that we're driving the market in. And the one thing I'll say is we're not being undercut by technologies that are even much less performant than we are. So we're able to go in with very compelling technological and performance-based proposals that are also very cost competitive and ultimately enable the business case of our market. And that kind of shows a lot of the traction we've been getting.
I think we can agree that there's a tremendous amount of activity in this space, but investors that may take a look at LiDAR stocks will see that, many of these names, including your own, have come under pressure. And I think, even Luminar stock is down something like 50% year to date, despite, having a commercial OEM contract with Volvo and a lot going on. So talk to us a little bit about kind of what are the catalysts to getting that relationship to scale and what are some of the milestones for you?
Yeah. I mean, the volatility is partially life as a public company. But I think that you touch on a really good point. Our goal is to drive long-term execution. If you look at the whole space that we're often compared to, these lidar companies, the first thing is that most of them have jumped to this stage of their business without having a book of business that really requires them to build this much of a runway effectively. We did that well before we've now become a public company, which gives us a lot more strong stability of basis to stand on. And as you suggested, this pipeline is really quite rich. In these kinds of new emergent markets, success kind of begets success. The kind of work that we did with Volvo, we spent a long time with them over a lot of years, way before they even wrote an RFQ, as it were, a request for quote, for a program. And so we do this with all of our customers, or at least as many as we have the opportunity to spend that early time working with them on their problem, understanding what they need to achieve all the way through function, so that we can make sure that our technology serves their needs. Now, the fact that we've been doing that for long enough aligns our roadmap very well with what we can do and what we can deliver now through our ecosystem to what they're trying to achieve. And so while the rest of the marketplace is trying to figure out how to put their sensors together to try to compete with what we're doing, we've already moved 2 steps beyond that, where we're showing the OEM what's possible with their vehicles. We're able to detect a child dummy for now, jumping out from behind the hidden cover behind a car 25 meters away from a car going 30 miles an hour. And we're able to identify that, assess it as a threat that's real, apply the brakes, and stop the car. This is not something that vehicles on the road today can do, because there's too much uncertainty in their detection. And so bringing that whole thread of requirements down from what do you need to detect, how much confidence you need, how much time you need to detect it, all the way down into how many measurements and points and at what range and what quality of measurement do I need in the sensor is really probably the biggest thing that differentiates us, which is why, I really kind of, again, urge to try to look through the spec sheet battles that exist out there and look to what's being done with the sensors, right? LiDAR is sufficiently complicated and too easy to spin into certain configurations that allow you to do certain things. But if you focus on what's possible with the functions, and that's really what we're executing towards, and working that pipeline to make sure we can bring as many folks in the marketplace along with that mission.
That makes sense. Most companies in the space seem to be focusing on level 2, level 3 autonomous driving, where there's still driver intervention and attention required. What do you think needs to happen from a technology perspective to get, to get commercial OEMs to feel comfortable, to meet safety standards, and to truly see that kind of mass commercial adoption that we want?
Yeah, so it's interesting, and I think it has significantly less to do with autonomy and what people think about as getting the human out of the loop. And it has a lot more to do with what we can do with these technologies to make the vehicle operate more safely, regardless of who's in control. Because we all know driving, our cars. I have a nice luxury car with lots of features, and I still don't trust it to do most of these things because I've seen it disengage enough. I've seen it not react to something that I probably figured that it should have. And it's that trust. And I think that's really what drives what we call proactive safety, and using this technology because of how much confidence it has of knowing the environment at long ranges, without all the false alarms that come along with cameras and radar, that allows us to build this safety envelope, from which self-driving can emerge, because that's ultimately mostly a luxury feature. There's of course some safety benefit to be had from a really good, always attentive robot driver, but if we can create that safety envelope with the technology in the first place, which is honestly even level 0. It doesn't sound very sexy, but level 0 are functions that are non-continuous. So automatic emergency braking is technically level 0. And a lot of these things that really will move the needle in the economic benefits of safety, avoiding crashes, not just making them less bad, is what's going to happen and move the industry forward. And as soon as we can create that safety envelope is when we can start confidently deploying level 3, level 4 technologies, and that's really the kind of basis that we're driving toward. And you look at Volvo. That's what's convinced them to standardize this technology in their vehicles, not the highway pilot that we're going to be driving towards, right? That's the upside. And I think that's really more and more the right way to think about it, both as a citizen of the world and as a business. Because finding economic motivations to standardize technology is a much more long-lasting movement in economic, as a business, than it is hoping for government regulation to say that now must all have Lidar, which is just going to drive the technology toward low cost at the expense of performance. And so if we can maintain performance, convince the economic case of safety and the upside of autonomy in these systems, that's where we see very exciting, very rapid adoption across vehicles, across automakers, and across the world.
All right. So you touched on this, idea of the safety envelope as
Yeah.
being the largest really addressable market for this technology. But what are your thoughts on the futuristic world of robotaxis and, level 5 autonomy? Is it possible? Is it a pipe dream? What technology changes do we need to get there? What are your thoughts?
Yeah. So a lot of people are talking about how Luminar's pivoting, right, from autonomy, and at the end of the day, it's really not. Our mission has always been to enable self-driving, right? Enable autonomy. Along that path is the identification that there's this need to deliver safety for autonomy, and that is tremendously valuable also to the consumer market. And so it's really something we definitely believe that robo taxis, robo trucks, all these kinds of things are possible. I mean, we've seen our customers do it, and I think that's really the thing that motivates. So I think as a business, the real question comes down to where are the markets that are viable and have strong demand now. So we're serving technology, our technology partners like Mobileye and Pony AI doing robo taxis. We spend a lot of attention trying to drive them forward. We look at our partners like Daimler Trucks and Trucking and a whole host of others to drive that market forward, so that, and then I should say, the group that we're seemingly focusing most on now with consumer markets is what we need to do anyway from a product cost scaling perspective to be able to not be the long pole when those markets are mature and actually pulling for demand and volume. And so everything we're doing now, still aims toward full higher levels of autonomy, because the sensing technology demand is still there. The level of autonomy has very little to do with the sensor performance as much as vehicle speed does. And so because we're looking at delivering safety at all speeds, because we're looking at doing highway autonomy, that drives the sensor requirements for all of these applications. You just need more of them to cover a larger field of view and other sensors for redundancy and things like that to do higher levels of autonomy. But the sensor itself needs to do the same thing. And so our roadmap to enable all of these great things in consumer vehicles is what we need to do anyway to make sure that autonomy can be realized down the road.
Right. Are there any other adjacent technologies that need to improve for autonomous driving to see mass adoption?
So I think the real long pole is ultimately going to be the processors. So the market is anchoring itself for this early wave of technologies in effectively supercomputers. Right? These are very rather expensive, high power consumption, very performant computer systems that bring all of this data in, process it to understand the environment in high confidence, and then build routes and things. And that is the point at which will ultimately be the cost driver and the power driver for these systems. And so that's the area that is being developed, but that's the kind of the way this all works. Once we define the systems, the architectures, and the compute can come down because it can be simplified. One of the cool things about Lidar is it's actually a much lower processing intensive data stream because it doesn't have all the superfluous data that a camera stream has, right? I don't need high resolution right here on this wall. It's a wall, it's flat, same color, right? And so LiDAR data gives you that more immediately actionable 3D data, but there's actually less data than a camera, which gives you lots of not very actionable information. So being able to find ways like that to leverage the different sensors to build the processing requirements gives a really nice roadmap to driving that down as well.
Mm. So you obviously have seen a lot of technology and you see a lot, what technologies that are on the horizon most excite you? What do you think is interesting right now?
Oh man, that's a good one. Um, Honestly, I think that the more we do with vehicle function, the more important it's going to be to understand how the now passenger, or changing between passenger and driver in the vehicles, are going to be interacting with the vehicle. And so this is something that we look at with our automaker customers, as well as other partners in the ecosystem, to see how can the system really come and be completed into the vehicle. We announced really nicely last week our partnerships with Webasto and an Alpha to figure out how to get all the sensors really nicely and cleanly integrated into the vehicles. But we need to think about also into the future, how do we integrate the person? So thinking about that as a system is really kind of an exciting space. Like, how can we give this data to a human who wants to be driving, but wants the confidence and the assurance that the vehicle system around them knows what's happening, can give good alerts, more than just lights on your dash. So that space is really kind of cool as a consumer and as a technologist, to see what's going to come down the pipe to that driver experience when the vehicle knows more than you do.
Matthew, thank you so much for joining us. We're really excited to see what's next at Luminar, and we'll stay posted.
Absolutely. Thank you so much for the opportunity.
Thank you.